Good afternoon, Year 9. Here we go. Today's lesson a little bit on efficiency. If you were in, then that's great. If you weren't in, then you can have a look at this and have a go at the task, which should be on the Teams. So here are some starters. Have a look at the starters first of all. Pause the video. Okay, and unpause. Now, because I'm a bit silly, I didn't actually put the answers on. So let's see if I can get a camera up and let's have a look here. So what are the units of energy? Units of energy are joules, J for joules, whoops, there you go. Or we could put Newton meters, okay? But this is the one we usually use, okay? What is work done? Work done is energy transferred, okay? If you put the formula work done equals force times distance, Fs, that's fine. But this is really what work done is, okay? How is GPE calculated? That's dead easy. GPE, gravitational potential energy, EP, is the mass times the gravitational field strength times the height. Next one, what happens to wasted energy? It usually gets turned into, or the proper word I should have used is transferred to what? Heat. Okay? Heat energy. And what is the law of conservation of energy? Now, this is one from Key Stage 3 that you should know. If you don't, I will tell you now. And if you don't know it, I would write it down also. Energy cannot be created or destroyed, comma. It can only be transferred or changed, transferred's the better word, from one form to another. Close question mark. Okay, so if you ever asked that question, what is the law of conservation energy? That's what it is. Okay, pause it if you want to write that down. I'm going to move on now, so let's get rid of that camera for a second and let's get back up on the screen. Okay, so thus far, oh, by the way, here's the objective. Very simply, calculate efficiency. Okay, so thus far, what do we know? Okay, we know that energy gets transferred from one form to another, and all these are just various types. Okay, now in all of the sort of examples we've looked at, we've been looking at the useful energy it's being transferred into. For example, when I'm riding my bike there in the bottom left-hand corner, there's me. Okay, the useful transfer is the chemical energy in my muscles into kinetic energy. That's useful. But there are some unuseful energy transfers being taking place there. For example, if I don't oil my wheels, I lose energy to friction. Okay, friction causes heat, also sound. Okay, so not all of the energy gets transferred into what I want it to be. Okay, the energy doesn't disappear, but it doesn't all get turned into what I want it to get transferred into. For example, in that case was movement. Look at the top on there, the crane. Well, the useful energy transfer is from the electric motor in the crane, transferring to gravitational energy of that block it's lifting. Okay, but not all of the energy from the motor goes into that because the motor has moving parts. They get hot, and so some of that energy is wasted. Okay, and that happens all the time. So energy efficiency is a measure of how good a device is at changing from energy from one form to another. Okay, so that's just a simple definition of what efficiency is. If it's efficient, it's good at changing or transferring the energy into the one we want. Okay, but this is a caveat here. Nothing that we ever make or build or design or whatever is ever 100% efficient. We always lose a little bit of energy. Even the human body isn't 100% efficient. I think it's about 60%. I don't know. Look it up. Okay, because we waste energy as heat, and we radiate heat and so on and so forth when we exercise. So devices aren't 100% ever. Okay? So the more efficient a device, the less energy is wasted. Is that fairly simple? And this is why we've transferred these days that from the old-fashioned light bulbs, which are filament light bulbs, which are very inefficient. They generated lots of heat, which we don't want from a light bulb. And these days we use these more fluorescent or filament or even LED type bulbs. They are more efficient. That's important. The big picture is running out of fossil fuels, we're polluting the planet with CO2. We want things to be efficient. We want our washing machines, our TV sets, our computers, our cars to be efficient, so we're not wasting lots of energy and creating lots of excess CO2 gas into the atmosphere. So that's why, really. Now then, let's get down to the nuts and bolts. Take a look at this formula. Fairly simple formula. On the top, we have the useful output energy. That's what we want to get out. And we divide that by the total that we put in. Okay, now that number that we calculate using this energy efficient formula is always going to be less than 1, because we've got the useful output is always going to be smaller than the total energy we put in. Okay, take a pause, make a note of that, and I'm going to move on. So let's have a look at this light bulb. The total energy we put in is 100 joules, and 45 joules ends up as light. So what energy is wasted? I can't hear you. Of course, 55 joules of heat. Okay, because 55 add 45 makes 100. What is the form of wasted energy? I've just told you it's going to be heat. And what is the efficiency of the bulb? Oops. Here we go. We can work that out using our formula. Write it out the formula, put the numbers in, get the calculator out. Okay, so our answer is its efficiency is 0.45. Now that means it's 45% efficient, and we can do this. We can write down efficiency as either a decimal, which is less than 1, or as a percentage. And it's a very simple case of just moving that decimal place 2 places to the right, and that gives us a percentage. Okay, easy peasy. Pause it, I'm moving on. Okay, answer this one. And I'm pausing. How much energy is wasted? We can do that. It's actually 204 joules of energy. Okay. What form is it wasted as? Whoops. In this case, it's heat. And its efficiency, look, is 32%. Okay. And there's the sum. Now do notice, look, whenever we're doing sums, we always write out the simple formula, put the numbers in, do the calculation. Is that fairly simple? Good. Okay, you can do this one, pause it and unpause it. Okay, this is slightly trickier because we know that it's 65% efficient, so we know 65% of that input energy gets turned into useful stuff. First of all, let's look at the useful output. TVs put out light and sound, that's what we want from them. And how do we get the useful energy? Rearrange the formula if we so want. In this case, we are finding 65% of the input energy. Okay, you should be able to do this in maths. We're just finding 65% of the input energy. That is our efficiency, because that is the energy that's been useful. Okay, so that's an example there of rearranging the formula. Okay, these questions, there should be a Word document somewhere on Teams. If not, you might be able to squint and see that. The lights have gone out again. And so pause it, I'm going to pause, and then I'm coming back now with the answers. Okay, here are the first 5. Notice that I've really quickly jotted down that equation each time. Okay, that's really good practice, and it gets it stuck into your brain. If you've written out efficiency equals useful output over total input, if you've done that half a dozen, 9, 10, or even more times, okay, it will stick in your brain. And so the next time you do it, it will just come to you. Okay, so they're the first 4 answers, and I think that little icon at the bottom's hiding that, isn't it? Oh dear. Oh, there you go. You see that 60%. Okay, and whoops, moving on. There's the other ones. Okay, pause that. Okay, some true or false questions. I'm just going to throw these up, see if you can get these. I think you might have seen some of these before. Okay, pause it. Are these things true or false? And here we go. Whoops. But you should get 10 out of 10 for them, because I know you've seen most of those before. Okay, good. Until next time, enjoy, and I hope that you get this idea about what useful energy is and how to calculate efficiency. If you go to YouTube and go to Free Science Lessons, the guy there does a nice video on it as well. Okay, and I'll try and get that link put into Teams. So enjoy.